like to welcome you into this fantastic YouTube channel that called Tanzania Online A-Level Secondary Schools in square bracket Olenjolai M. This channel specifically I have designed or I've developed, I have been designing a lot of materials, and even the way that I can teach A-level students at the distance place or by using the digital tools that we call them, or digital technology. So you'll be enjoying a lot of lectures and a lot of things and different ways of the tricks and different ways of learning advanced physics. And then the subject that we'll be learning today is advanced physics, and the main topic is mechanics, and the topic that we are still discussing is gravitation. And in case that you want to join us, in case of your Thanksgiving offering, that you want to offer your freewheeling offering, you may do on that mobile number. And then this is lecture or sessions or period 8. If you've gone through the lecture 7, I left the homework for you to do, and then so you have been doing the problem solving on the satellite motion. That's what we've been discussing, that's what we've been learning from the beginnings of the lecture 7 to the end. But before we started today's concept, I would like also to add one question from the Principle of Physics book, S-Chant, and this is for the class 11. I'd like to add one interesting question, and then I would like to give you some of the uses of artificial satellites, and then we'll go to the concept of the day. Okay, so we have again, will be example 12, if I'm not mistaken, and then you have to refer Principle of Physics. This we call the S-Chant is Principle of Physics. S-Chant is, so this is S-Chant is Principle of Physics. Okay, Principle of Physics. Page, the questions is, you'll find it in page 699. So the question is not difficult, but it's a little bit tricky. The question states that a satellite is revolving. The satellite is revolving in a circular orbit at a height of 3,400 kilometers above the Earth's surface. Above the Earth's surface. Okay, above the Earth's surface. Calculate the orbital velocity. Calculate the orbital velocity. Calculate the orbital velocity and the period of revolution. And the period of revolution given at the radius of the S, and this we have RE is 64,000 kilometers, 6,400 kilometers, and acceleration due to the gravity is equal to 9.8 meters per second square. So solution. So let me write the solution and then read the question carefully. So let us read the question the way it is. It's a little bit tricky questions, but yeah, so you see that it has two parts of the question. A satellite is revolving in circular orbit. So you have to know the orbit is not a spherical, it's a circular orbit. At the height of 34 kilometers above the Earth's surface, calculate the orbital velocity, that's what required, orbital velocity, and also and the period of 40 of revolution of the satellite, right? Given that the radius of the Earth is 64,000 kilometers and acceleration gravity is 9.8. So you may do these questions because everything I have taught you, all the concept. So let us follow these steps on solving. So data given. So the data given, we say that the first piece of data is we say that the height of the orbit or the height of the circular orbit. So the height of the circular orbit is equal to h is equal to 3,400 kilometers, right? And then we say that above the Earth's surface. Then we'll be given what? Radius of the Earth. So radius of the Earth is equal to 6,400 kilometers. Then we'll be given g, 9.8 meters per second squared. So what does the questions need? The questions need what? Orbital velocity. So that's what you have to find. Orbital velocity, we call it Vs. It's not the escape velocity, so this is what required. Okay? And then we have what? We have a period, which we call the T of the satellite. This also is required. So the second step, sketch the orbit, or sketch the satellite orbit. The satellite orbit. Sketch the satellite orbit. So this is the Earth's surface. Here we have center of the Earth, and this the mass of the Earth. Again, here you have radius of the Earth, which is RA, and then this is the point. So here we have the height above the Earth's surface. You can even just introduce it here. So at this point you have the mass of the satellite, MS, then have even ST, satellite, mass of the satellite, and then this is still the radius of the Earth. Here we have radius of the Earth, here radius of the Earth. So this is the height. So what is required? The orbital velocity, the Vs of the satellites. What will be the orbital velocity for the satellite to revolve in this circular orbit? So this we call the orbit of the satellite. Orbit of the satellite, and this is the Earth's surface. Earth's surface. So this is the Earth's surface. So then what we say that from gravitational, from Newton universal, or from Newton gravitational, from Newton's universal gravitational law, we say that this is the steady state. Steady state, you have to recall Newton gravitational law. I mean that recall the formula of orbital velocity. I told you, but in case that you forgot, you should use the force of centripetal. Simply that if you forgot, you have to equate the force, the centripetal force, and the force of attraction. So simply, in case that you forgot, we say that the mass of the satellite times square of the velocity of the satellite, then over radius of the Earth, like this, radius of the Earth, then plus what? Plus h. This one, this is centripetal force, right? Is equal to mass of the satellite times mass of the Earth times universal gravitational constant g, and then radius of the Earth plus the height h, then square. So we can simplify this. So you find that the orbital velocity of the satellite is equal to mass of the Earth gravitational constant over radius of the Earth plus h. But I told you and I showed you that g times radius of the s square is equal to universal gravitational constant times mass of the s. So this is equation 1, or this is equation 1, you can call it, this is equation 1, and this is equation 2, this is equation 3. So if that the fact, we say that orbital velocity is equal to what? Is equal to g radius of the s square over radius of the s plus the height h. So it means that you have to find the square to both sides. So that's why I taught you that, and I would like to remind you, there's no need for you to claim the formulas in physics, or whether in physical chemistry, no need for you, or in general chemistry, no need for you to claim the formulas. You have just to remember where should you start and what are the steps you have to follow. Well, if you are good in claiming, for this case, you may recall this formula, but it won't help you on mastering the concept because we have many formulas in physics, especially in mechanics, right? So you have the formula for the orbital velocity, and that's what you've been asked to find in this example 12. Enjoy the beauty of physics, okay? More than the way I enjoy, you have to love physics. That is the main goals of this program. So the orbital velocity for this case now, we say it is the square root, not the cube root, okay? Square root of what? Acceleration gravity, which is 9.8 times what? 6400 exponent 3, which is the radius of the s square, radius of the s square, and then we have what? We have the summation of 64,000 plus 3,400 kilometers. This one should be exponent 3. So you have to use your scientific calculator, right, to do the computation to find the orbital velocity. So we have to take 6400, then exponent 3, 6400 times 1000, and then it should be squared, should be multiplied by 9.8, should be divided by 64, so it will be 998, 8000 exponent 3. Then you have to find the square root of the response. So the response will be 6.4 exponent 3 meter per second. 6.4 exponent 3 meter per second. So therefore, the orbital velocity. The orbital velocity of the satellite is 64,000 meter per second. So to travel 6.4 kilometers in 1 second. That's the minute. So that's about orbital velocity. The second part of the question asks us to find the period of revolution. Find the period of revolution. Say period of revolution. Because these satellites will be revolving the Earth's surface. So you have to find the period of revolution. How do we find the periods of revolution? Okay, so we've been following how many steps? 3 steps. So this is the first step of computation. First step, we have to do computation. Okay, so the 5th step now, we say that we have to compute it. We have to recall, right, the formula of determining what of period of the satellite. So how do we do this? Okay, so we say that we have to recall the formula, the fundamental formula in we call it in motion during our form to that the time is equal to the distance always over velocity. For our case, the time of revolution of the satellite, we call it the period, is equal to what? Is equal to the circumference. This is circumference of 40 of satellite orbit divided by what? By orbital velocity. Divided by orbital velocity. So the period of the satellite is equal to circumference of the satellite. This is twice by the circumference of the orbit of the satellite, or satellite's orbit. This is circumference of satellite orbits is equal to radius of the S plus the height above the S's surface of orbital velocity. So the period of the satellite is equal to twice pi, then radius of the S is 6400 kilometer, right? In terms of, okay, so 6400 kilometer. Then the height of the orbit from the S's surface is at 400 kilometer. So exponent 3 in general of orbital velocity, which is 6400 meter per second. And this one, remember that is meter, so this is meter, so meter and meter will cancel. So the period of revolution, you have to use your scientific calculator, compute it quickly as well as possible. So you have to take 64,000 and then plus 3,400, and then you say that this one times 1,000, and then times twice alpha pi, and then divided by 6,400. So it is 21.3 seconds. So if you estimate, you might find that yes, seconds. So if you express it in hours, so this is 61.6. Why? 6,400 plus 3,400 times 1 exponent 3 times 2 times 3, 21.4, then divided by 6,400. So it is, yes, it is 9616. Do the minor correction. It is 9616.25. So if you want to express the period in hours, it means that you have to take 9616.25 seconds divided by 3,600 seconds, or in terms of hours. It means you want to express in terms of hours. So the response divided by 3,600, then we get is 2.67 in 2 decimal places hours. So we say that the period of revolution of the satellite is 2.67 hours. You may leave even your response in seconds. You are not limited. So you may put in seconds, you may put in minutes, you may put in hours. So you have the choice. So I believe that up to this moment, you're competent enough in solving problems regarding the artificial satellite. So let's just to end the subject of the satellites by just giving you uses of artificial satellites. What are the uses of artificial satellites? So that's the question. Okay, so this is, we say, example 13. Okay, we say that mention 6 uses of artificial satellites. In case of exams, each use will have half marks means 0.5 marks. So maybe be given 3 marks on answering that question. So the satellites, we say that, so solution, the artificial satellites, the tomato sentence should be artificial satellites have many uses in our daily life. Some of the uses are, number one, these artificial satellites, they are used to forecast the weather. They are used to forecasting weather, for weather prediction. Whether tomorrow is going to rain, we watch in television, we watch online, but we don't know where does these meteorologists or meteorologists means that the weather specialists get this information that tomorrow is going to rain. And you know what happens? Sometimes when they predict the rain, tomorrow is going to rain. Or maybe tomorrow is going to be sunny. So we don't know where they're getting the information. So from today you have to understand that there are satellites special for the weather. We call them weather satellites, right? So they provide the weather informations, and there's a special algorithms in those supercomputers for the weather forecasting that will be given all of those essential data, temperature, the air temperature, the air pressure, maybe we call this solar intensity, soil humidity, very important parameter for the weather, soil humidity, and even the soil temperature, very important parameter. Yes, and even the rain, we call it rain or precipitation, rain precipitates, are very important also in the weather forecasting, right? So the second use, we say that they are used to learn about atmosphere near the Earth. So these artificial satellites, they are used to learn. So scientists learn about the atmosphere, near the Earth. Near the Earth. And then they said they are used to start radiation from the sun and the outer space. They are used, the artificial satellites, they are used to receive, transmit, and they receive various radio, means broadcasting radio, and television signals. So simply they are used in communications or in transmissions of the message to a large number of people or large number of listeners simultaneously. They are used to start radiation from the sun and out of the space. They are used to study radiation from the sun. Radiation from the sun. Okay, radiation from the sun and the outer space. In the outer space. So I still have to give you 2 uses of artificial satellites. Then we go to the next concept. space flights are possible due to artificial satellites. So they are used for space flight. So you say that space flight. So going outside of the space of the Earth, space flights are possible. So space flights are possible due to artificial satellites. Artificial satellites. Then number 6, you say they are used to know the exact shape and dimension of the Earth. Used to know the exact shape and dimension or dimensions of the Earth. So those are the 6 applications or uses of 40 of artificial satellites. In case you have any questions, don't hesitate yourself, ask in the comment section. Make sure that you do the homeworks that I've left you in lecture 7 or in period 7 or session 7 of gravitation. Make sure that you go through them. There are a lot of things that I might teach you concerning about artificial satellites or concerning about the satellite. The subject of the satellites is broad. That's why that I've been taking care, or I've been limited by the syllabus of advanced secondary schools for United Republic of Tanzania. So doesn't mean that at the ends, but I've given you the fundamental, the whole picture of the artificial satellites or the satellites. So you are allowed to go far as well as you can. So you're not limited to end where I've ended, but at least that now I'm free to teach you some other new concepts. And the concept that which I would like to teach you is called the gravitational potential energy. So this is called the gravitational field, the gravitational potential, and gravitational potential energy. So allow me now to teach you about the gravitational field, Newton, gravitational field, and then allow me also to teach you another technology called the gravitational potential, and also allow me to teach you about gravitational. These are different technologies. Gravitational potential energy. Don't mix them. Gravitational potential energy. Gravitational potential energy. So I'll be teaching you one word after the other word. And I will even teach you about the work done, something we call the work done, which is very important for you because the fundamental. So let us start with the first term, we call it the gravitational field. So this is the first terminology that you have to cover. So the basic question is, what is gravitational field? What is gravitational field? Say it, gravitational field. Write it in your mind. Gravitational field. Say it again, gravitational field. Gravitational field. So it's a region of space around the body in which any other mass experiences. I have found 2 definitions of this terminology. So as I told you that you have to pronounce it so that you can register in your permanent memory. Because you need to know the definition of this term during your review. So gravitational field, we say that is a region. Is a region or space around the body in which any other mass, any other body or any other mass experiences the force of attraction. Force of attraction from the other body. Or some of the books define this term gravitational field is a region whereby gravitational force, whereby the gravitational force, gravitational force between bodies is experienced. This is a very interesting term. We say gravitational field is a region or space around the body in which any other mass experiences the force of attraction. Or is a region whereby the gravitational force between the bodies, whereby the gravitational force between the bodies is experienced. So is experienced. That's the definition of gravitational potential. Gravitational field, potential. So gravitational field, this is the region whereby two bodies experience the force of attraction. So in case that you have two bodies in a certain space, and then there's no force of attraction between them, then we say that those two bodies are out of gravitational field. So we say that the space or around the body in which any other mass experiences the force of attraction. So what does it mean? So suppose that we have the S, right? This is the S. This is the S's surface. This is the center of the S. Right? So because we have the S, and then we say that, and we assume that the S is a cycle, or we assume whether the S it is an orbit, depends. Okay. So we say that the mass of the S, and then we say that suppose we have a body at this point. This is a body of mass M, and then we find that the S will have experiencing the force of attraction. Remember that, for instance, that we have these lines. So this we call the gravitational field of the Earth's surface. Gravitational field of the Earth's surface. So this is the body of mass m, and that the mass of the Earth. So suppose that this is, we call it the gravitational field. So if the force of attraction